Okay, so we are discussing about the fuel injection system in SI engine right now. And then after that, we will discuss about the CI engine. In SI engine, we have already discussed about port fuel injection system. And we have discussed in details about the port fuel injection system, in which we have discussed that how it is integrated with the engine and what are the different parts is required, how logically it it communicates with the engine or engine control unit, where the injector has can be located, and what is the demerit of the PFI engine. These are the some of the things we have already discussed. So when we were discussing about PFI engine, then we came across one of the demerit is that valve waiting. And that is a big problem, particularly in the cold start of the engine. Okay, we need to inject more amount of the fuel than it is required so that the engine can start initially. So there is a cold start problem. Valve waiting is the problem. Okay, so these are the major problems of the port fuel injection system. So how the further what we can do if we know that all technology has some merits and the demerits. So people start thinking about that why not we can inject the fuel directly into the combustion chamber in SI engine, just like the diesel engine. And then from there, the such kind of concept in which you are injecting the fuel directly inside the combustion chamber in SI engine. If in your car has such kind of the technology, then such kind of the technology is called gasoline direct injection, GDI. Okay, GDI. In fact, we have also discussed these slides, but let us once again discuss it. What happened? Yes, so we can see here that we have a spark plug, and then here we have fifth is our injector, and the opening of the injector in such a way that the jet is directly coming into the combustion chamber, unlike the PFI engine in which jet comes out in the intake manifold. Sixth is the rail in which the high pressure fuel is accumulated there and through which the injector is connected. And the rest of the things is that the valves are here. So in the last class, we also discussed that if in SI engine, it is if an SI engine, it is equipped with GDI technology, then our traditional statement in which we have studied till now that the fuel and air mix in outside the combustion chamber in SI engine is not going, it no longer going to be valid, and it is only air comes into the combustion chamber during the intake stroke in the GDI technology. And the shape of the piston, we also discussed that in GDI technology, the shape of the piston is no longer, the top part of the piston is no longer is going to be flat. It has a very complicated kind of the shape. So that's the what we have discussed already in the last class. And then from here, let us start that if you go a little bit details in the gasoline direct injection system, then we will come we will come across two terminologies. One is called homogeneous combustion and another is called stratified combustion. Or we can say that GDI technology has two mode of the combustion. Two mode of the combustion, it means we have a two way that we can inject the fuel and we can have a different kind of the combustion. So there are two modes of the combustion in the gasoline direct injection system. One is called homogeneous combustion. Another is called stratified combustion. Right now, in the market or in the production, whatever we have a GDI, mostly or all of them probably we can make a statement are running on based on the homogeneous combustion mode. Okay, a stratified combustion mode is still under the developing stage. Okay, or for the demonstration purpose, but it has some limitations. It is still under the developing phase, but it has a wide range of benefits. And I'm hoping that one day it is going to be a mature technology and IC engine is going to be benefited with so many good things from the stratified combustion mode of the GDI. What is the difference? Okay, what is the difference between the homogeneous combustion and stratified combustion? Last class, we also just discussed that combustion in the SI engine is also called homogeneous combustion. It means the fuel and air has enough time to mix with each other and form a homogeneous air fuel mixture. And particularly, this statement is very much true when we have a fuel injection in the intake manifold. And diesel engine is called heterogeneous combustion. Now, in GDI engine, we are injecting the fuel directly into the combustion chamber. Now, depending upon when, but in any way, one thing is sure that we have to little bit compromise with the homogeneity level in the GDI engine as compared to it's a PFI part of the system. However, the homogeneity level can be improved in the homogeneous combustion mode when we inject it, when the fuel injection takes place during the intake stroke at a high pressure. So in homogeneous combustion mode, the fuel injection takes place in the intake manifold or in the beginning of compression stroke, or the end of injection may takes place at max at the beginning of the compression stroke. Okay, and the fuel injection is going to be takes place at the high pressure compared to the PFI part. PFI, as we have studied, it has only 3 to 5 bar. In GDI, gasoline direct injection part, the fuel injection, particularly in the homogeneous combustion mode, the fuel injection pressure can vary, or it can vary from 50 bar to around nowadays 200 bar. 50 bar to around 200 bar. So now you can see how much the fuel injection pressure has been increased. So even though we are injecting the fuel directly inside the combustion chamber in the intake stroke, but the fuel injection pressure is very high. So the fuel droplet size is going to be a smaller, and it can form a homogeneous, or in that way we can maybe we can say we can compare the homogeneity level of the GDI homogeneous combustion mode with the PFI mode also. So basic thing is that in homogeneous combustion mode, the fuel injection takes place in the intake stroke itself. Now, when in the intake stroke is going to be takes place or in the beginning of the compression stroke, it depends upon the optimization of the engine. Or when what is the optimum fuel injection timing? So here, the fuel injection timing is very critical parameter, even though it is a liquid fuel. We studied in the PFI mode that fuel injection timing is not has very critical, it's not a very critical parameter if it is a liquid fuel. That is true for the PFI mode. But in the GDI mode, gasoline is a critical. Fuel injection timing is a very critical parameter. So now the one parameter is further increased to optimize it. Fuel injection timing as well as fuel injection quantity. OK, both. That is going to be quantity. Let us suppose we can say that it is a stoichiometric mixture. So the air quantity is going to be remains fixed as per the given amount of the air. But the fuel injection timing and fuel injection pressure, both are going to be now variable. And we need to optimize it in order to get the best power output and the minimum emissions, lower fuel consumptions, whatever we have our objective. Now, when we are injecting the fuel directly inside the combustion chamber, then the valve wetting phenomena is completely removed in the GDI technology. So whatever the fuel you are injecting, it is all of them are coming into the combustion chamber. There is no possibility in the PFI. There was a possibility that some of the fuel can stick on the backside of the valve or in the manifold, and not all the quantity that is injected come into the combustion chamber. So from our calculations point of view, our air fuel ratio has to be a certain values, but since not all the injected fuel comes into the combustion chamber, so the actual air fuel ratio inside the combustion chamber has some problem in the PFI mode. But that part is completely, or that problem is completely removed from the GDI engine. So that is the one of the benefit. So, and the cold emission or cold emissions, particularly or cold starting problem, has been also improved in the gasoline direct injection system. So homogeneous mode, sometimes we also say that in GDI mode, in GDI technology, homogeneous combustion mode is used to improve the emission of SI engine. OK, a stratified mode of the combustion is used to improve the fuel consumption or to reduce the fuel consumption. So that is very much true. That homogeneous mode we used mainly to reduce the emission, like our cold start problem or SC emissions. And stratified combustions, when we discuss in the details, we'll find it out this technology is very good to improve the BSFC or fuel consumptions. But here there is a problem in the GDI. When we will study about the emission, and there is some emission standards, at that time we will discuss in details, but here I would like to give some things. That particulate emission, okay, a particulate size emission or size distribution. In SI engine, if it is a port fuel injection, then there is a no emissions regulation or emission restriction on the particulate or soot particles, because it is understood that it is a homogeneous mixture and there is a no big problem with the particulate size. But in the GDI, when SI engine is equipped with gasoline direct injection technology, then the manufacturer has to satisfy the particulate size emissions also to the regulatory agency before it can be launched. Because here we are compromising with little bit with the homogeneity level. So that is the one of the challenge. And then obviously the cost is going to be a bit increased because here the fuel injection is going to be is taking place at high pressure. So obviously you have to use the fuel pump of as a very it's a higher fuel pump. It is not only the small pump is going to be okay as per the PF5 engine where the fuel injection pressure was 3 to 5 bar, but here we are dealing with 50 to 200 bar. So the fuel injection, the pump itself is going to be costly. Okay, then we need a fuel rail. Fuel rail has to be some kind of sensors also. Okay, then control technology is going to be changed. There are so many complexity about the calibration is going to be come out, but the benefit is that we can have a direct control or even more precise control over the air fuel ratio and the emission. That is the story of the homogeneous combustion. In stratified combustion, okay, what happens? What is the idea? The idea is that the one thing is that the fuel injection takes place towards the end of compression stroke. It's very much similar to your diesel engine that we are injecting the fuel towards the end of compression stroke. In homogeneous mode, the fuel injection was taking place in the beginning in the intake stroke, but in a stratified combustion mode, we are injecting the fuel towards the end of compression stroke. Now see also the piston position. The piston is almost reaching at the top dead center. At that time you are injecting the fuel. The shape of the combustion chamber is very much complicated kind of the things. Stratified. What does it mean? Stratified. Stratified. It means the homogeneity level inside the combustion chamber will vary a lot. It's very different. The shape of the combustion chamber, orientation of the injector. Okay, the air motion inside the combustion chamber in such a way that when fuel comes into the combustion chamber, okay, it can deflect it with the shape of the piston and it goes at the tip of the spark plug. And we found at that time a spark is going to be created and the combustion is going to be takes place. So the air fuel mixture near the spark plug is almost like a stoichiometric, and the remaining zone of the combustion chamber is very lean mixtures, or even there is a no fuel also. So a stratified combustion mode, the combustion chamber shape, the air motions inside the combustion chamber, the orientation of the injector is such a way that the air fuel mixture is closer to the stoichiometric near the spark plug, and the rest of the combustion chamber is a very lean mixture, or there is no combustion or there is no fuel, and that's why it is called stratified. So the air fuel mixture is very heterogeneous in the stratified combustion mode. Why it is like that? Because we consider that when engine is running on the highway at a constant speed, there is no acceleration is required, and it is just to maintain the speed. Okay, we need to just maintain the speed. Then it is possible to create a stratified air fuel ratio inside the combustion chamber. Just enough engine will produce the power just enough to maintain that constant or that speed. Whenever the acceleration or such power is required, then the engine control technology has to be in such a way that it will shift from the stratified combustion mode to the homogeneous combustion mode. Okay, and then we are going to utilize the more power and output from the homogeneous combustion mode and to have accelerations. And once again, when we need to maintain the just constant speed, the combustion has to be shifted to the stratified combustion mode. So in GDI engine, the overall the concept of the GDI engine that depending upon the requirement of the power output and or control technology, that both combustion mode can be shifted from homogeneous to stratified or stratified to the homogeneous depending upon the requirement and depending upon the control technology. So in a stratified, that's why I told you that here we need our engine is just producing the power to maintain the speed. So here we are saving the fuel. So that's why initially I made the statement that the stratified combustion mode is very good combustion way that we can save more fuel and we can and the homogeneous combustion mode is mainly used for the either the acceleration point of view because it can produce more power and from the improving the emissions point of view. So when a GDI engine or GDI vehicle has both kind of the combustion mode, and then you can imagine how difficult is the control technology. Control is very complex is going to be happen is if the GDI has both sort of the combustion mode. Another problem with the challenges, it's not the problem, the challenges with the stratified combustion mode that how we can improve or how we can increase the operating range because operating range to create the stratifications of the air fuel mixture because at very high speed or at very high load condition, stratifications maintaining the stratifications is a bit difficult. To achieving the stratifications over the wide range of the operating condition of the engine, it is one of the major challenges. And then transition or the shifting off from the homogeneous to a stratified or there is a transitions period. It's a overall these are the current problems right now associated with the GDI technology if it is a combined homogeneous and stratified combustions. And therefore I told that most of the GDI engine as of now it runs on the homogeneous mode. Still the both mode is still is not in the production stage. It is still under the developing phase. Some of the company they do they have some kind of the engine only for the as far as I know is only for the demonstration. I think yeah.
Sir, how does air fuel ratio is controlled in the homogeneous?
What is?
So how does the air fuel amount is controlled in the homogeneous combustion?
Homogeneous. Yeah, that's the same way that we control the air or we what is called control the air fuel ratio in the PFI mode. Only thing is that we have shifted the injector into the combustion chamber mode. So here the same way during the intake stroke. OK. Now there's a your question is like OK, so we have to measure the how much air flow rate is coming inside the combustion chamber and it is a stoichiometric air fuel ratio. So we know the mass flow rate of the air. Accordingly, we can inject the fuel quantity to maintain the air fuel ratio stoichiometric.
So, sir, in homogeneous combustion, we have to maintain in the whole volume the stoichiometry,
Yes,
and in the stratified combustion, we have to maintain it at a tip of the spark.
exactly. That is the difference.
So this optimizes the fuel amount.
Yes.
Okay.
Any question? As far as the our uh, um, part or what I want to just introduce this concept to all of you. OK, we are not going into too much details, just the overview. I'm giving it here. Details is available in the book, but as of now, from the academic point of view or from our syllabus point of view, it is not required. Okay, but anyway, if you have an interest, please meet me. We can have a long discussions, but as far as our syllabus is concerned, I will not go into too much details. Okay. But if you have any questions, please ask. Some of the differences has to be very clear in the mind that what is the difference between the GDI and the PFI mode. Okay. What are the merit and the demerits? What are the different combustion modes of the GDI? Okay. What are the challenges associated with GDI? All these things, I hope we have covered it, and you will remember. If you have any questions related to that, you may please ask. These two technology is currently in used as far as the passenger cars is concerned, or any advanced SI engine. Okay. Carburetor, as I told, it is only used nowadays for the two-wheeler, some of the two-wheeler. Okay. Because in some of the two-wheelers, we have a PFI system also. Can anyone tell me any name of the bike which has the PFI combustion mode or PFI fuel injection technology? Two-wheeler. Any bike which has PFI technology? Most of us, what we have, as I discussed with all of you, is Scooty or Splendor and all these things, a Hero, all of them have a carburetor system. But I'm asking that two-wheeler that has a PFI. Some of the things I assume that most of you have very good interest in F1 kind of the race. So those who have an interest, I think these are the things is very common for them, and they know all the sort of the things. Any one of you are interested in the F1 race? No? Anyway. Okay, so we are stopping here now about the SI engine fuel injection process. And now what we are going to discuss about the fuel injection system in the diesel engine. Okay, so what we have a plan, or what I have planned for this course right now. We'll discuss about the diesel engine fuel injection system. Then probably we can cover some spark ignition system in the SI engine. So that's all. Then slightly we will touch about the combustion. Or I don't know, maybe we can leave it about the combustion because you are already doing the experiments related with the combustion. So, and then if it is, but anyway, slightly I will touch at least one lecture. And then we'll go to the emission, because emissions I would like to give you the little bit flavor and about the then alternative fuels. So this is what I have a plan for this coming classes. Okay, so now let us discuss about diesel engine fuel injection system. What happens? My computer runs very slow. Yeah. Diesel engine. First of all, in diesel engine, okay, what we have studied that diesel engine in which during the intake stroke, what is the only air comes into the combustion chamber. Okay. There is a no throttle in the intake manifold. So the accelerator directly controls the quantity of the fuel that is going to be injected into the combustion chamber. These are the things we have studied. Then what else we have studied? We have studied that air-fuel ratio in the diesel engine has a wide range of variation compared to the SI engine. SI engine most of the time runs on a stoichiometric air-fuel mixture. Diesel engine rarely runs on the stoichiometric air-fuel mixture. It is always runs towards the lean air-fuel mixture. So if you see the range of the air-fuel ratio in the diesel engine from no load to the high load and low speed to the high speed condition, you will find it out the air-fuel ratio may goes up to 65 even, okay, to around 20. That is the high speed high load condition. Whereas the air fuel ratio stoichiometric is very close to 14.6 or 14.7, but 18 or 20, that is the what we are coming closer to the stoichiometric conditions. Otherwise, in the linear conditions mode, where the engine is in the idling condition or slight low speed, low load conditions, is varying around 60 to 70. So there is a wide range of variation of the air fuel ratio in the diesel engine. And okay, so for a given engine speed and engine geometry is anyway the air flow rate is going to be constant, and then by changing the amount of the fuel input energy, the load on the engine is going to be vary. So that's why I told you that there is no throttle in the accelerator. There is no throttle in the intake manifold in the diesel engine. Your accelerator directly controls the quantity of the fuel that has to be injected, and the fuel is injected directly inside the combustion chamber at the towards the end of compression stroke at very high pressure. These are some of the things we have already studied previously. Now we are going to focus on only the fuel injection part. Fuel injection part towards the end of compression stroke. What does it mean? We have also studied that the fuel injection, it may occur in the range of from 20 degree before top dead center to around top dead center, or even beyond that top dead center, because fuel injection has a range and that can vary even after the top dead center also, depending upon the optimization. Now, diesel engine has a even more compression ratio. It has a higher compression ratio compared to the SI engine. So when we have to inject the fuel towards the end of compression stroke, then you can imagine that, or you can find it out just ideally, that what would be the motoring pressure. Motoring pressure, it means, or there is a no combustion or peak motoring pressure. So let us suppose the compression ratio is around 17.5. Okay. Take the gamma value around 1.3 or 1.35, and PV gamma is equal to constant, and then find the value of P1 is take it as a 1 atmospheric pressure. P2 will come something around 40 to 45 bar. So towards the end of compression stroke, it is going to, when depending upon when you are injecting the fuel, okay, you are going to encounter the back pressure at around from 35 bar to around 45 bar. Or even more than that, because the combustion is also going to be a start and the fuel is still coming in. So the combustion pressure is also going to be added. So what I'm trying to say here, the fuel injection environment in the diesel engine is completely different than what we have studied in the SI engine. It is taking at completely different environment at very high pressure, even and high temperature also. So the fuel injection system has to be also is completely different kind of the system. Other than that, before going into the what kind of the technology we are right now is being used, we have to see that we are injecting the fuel directly inside the combustion chamber. Okay, just before the start of the combustion. In fact, we can say, okay, even though it is not true, I mean, it's not actually true, but it's very much a very closer, that a start of fuel injection can be considered as a start of combustion. Here I'm neglecting the ignition delay. So the fuel injection and the combustion is going to be happen. A start of the fuel injection and start of the combustion. It is almost going to be takes place simultaneously, slightly delay. Okay. So now we can think about what would be the heterogeneity of the air fuel mixture in the combustion chamber. And therefore, we have discussed these things in details previously, or we have made such kind of a statement that when you are designing the SI engine or SI engine, then one of the important objective is to how to improve the volumetric efficiency of the engine, because we are throttling the air in SI engine. When you are designing a diesel engine, then our one of the most important objective is to how to improve the homogeneity of the air fuel mixture so that the combustion can be smooth, okay, and the emissions can be reduced as much as possible. Because here there is no time, so the homogeneity is going to be dependent on the fuel injection technology and the air motion inside the combustion chamber. These two things are responsible to distribute the fuel inside the combustion chamber. So the fuel injection technology is one of the heart of the diesel engine. We need to control the fuel injection technology. We need to advance the fuel injection technology. It needs to be consistent improvement in the technology so that we can meet the future demand. Future demand in terms of the emission. Diesel engine controlling the pollutants from the diesel engine is much difficult than the SI engine. Why? We will discuss in the emissions part, but here I'm just making this statement. And that is, so the fuel injection system is going to be a very important. When we are going to concentrate on our just diesel fuel technology or the diesel fuel process, what we can say? We are injecting the fuel at very high pressure through a small orifice in the injector directly inside the combustion chamber. So when liquid fuel is coming at very high pressure through a small orifice, what it is going to be happen? It is going to be liquid fuel is going to be disintegrate into the small droplets. And that process is called atomization. So atomization is going to be first of all takes place, and the liquid fuel is going to be disintegrate into the small droplets. These small droplets will penetrate into the combustion chamber depending upon other factors, and it will go into the combustion chamber. During that, the droplets is going to interact with the high pressure temperature air. It will absorb the heat from the air combustion chamber and it will vaporize. Fuel is going to be vaporized. And our objective in the designing of the fuel injection system or in the diesel engine, that how fast this fuel vaporization is taking place as soon as fuel is comes into the combustion chamber. Once it is vaporized, then the fuel vapor and air is going to mix with each other. Okay, air movement, tumbling or swirling kind of the motions is going to take it out fuel and distribute across the combustion chamber, forms the air fuel mixture, and then wherever the thermodynamic conditions is going to be suitable, thermodynamic condition like air fuel ratio and the pressure and temperature, then at that point the combustion will start. So if you see the distributions of the instantaneous distributions or the local distributions of the air fuel ratio inside the combustion chamber, it can vary. At some zone of the combustion chamber, you might find it out it is a within the combustible range or it is a stoichiometric. Some zone it is a very lean mixture or somewhere it is a rich mixture. So it has a wide range of the variation of the air fuel ratio variation inside the combustion chamber. Globally, we can say it is a 65 or 50 or 18 air fuel ratio. But local air fuel ratio inside the combustion chamber has a wide range of variation, too rich, too lean, stoichiometric. So automation is very important. We need droplets of very small droplets, okay, so that it can vaporize very fast. Now, to improve the automation, what we need to do? Automation depends upon the several factors. It depends upon your hardware and as well as it is going to depends on the fuel properties, and it also going to depends on the environment in which it is going to be injected. For a given engine, environment or hardware is going to be same. Optimizations, how we are going to the affect it too much for a given engine with the help of the fuel injection pressure. We need a very high pressure. We need to inject the fuel at very high pressure so that it can disintegrate into very small droplets as well as it can travel in the farthest corner of the combustion chamber also, because penetration of the fuel is also going to be dependent on the momentum of the small droplets. And then if it is going to disintegrate in very small droplets, the fuel vaporization will take very fast. It will mix with the air and instantaneously it will be available for the combustion. Therefore, in diesel engine, the fuel injection pressure is much higher. It is required to be very high. The fuel injection system has to be enough capacity or enough what we can say enough capable to provide very high pressure. Very high pressure, it means what? Till now, what are the things we have studied? We have studied that in PFI, it is 3 to 5 bar. In GDI, we studied about 50 to 200 bar for the homogeneous diesel homogeneous GDI. Now here I'm saying very high. Very high, it means right now, whatever the latest technology we are using in the diesel engine, with that technology, the fuel injection pressure can be varied from 200 bar to around 2000 bar. 2000 bar. Okay. Now some of the companies claiming that their fuel injection technology even can inject the fuel with that system. We can inject the fuel at 2400 bar. So that is what I'm saying. That the fuel injection pressure is very high. It needs to be very high to get the improve air fuel mixture at very high pressure, that is around, it can vary over 200 bar to around 1500 or 1800 is very common right now. Okay, all the diesel engine, whatever that they have a technology and a fuel injection technology, it is varying from 200 bar to around 1500 or 1800 bar. Some of the engine may have a 1800, 2000 bar also. Okay. Now, it is not the only injection pressure. Okay. But we need to think something else also. Okay. You remember we have introduced one of the terminology that is called multiple injection in one cycle. That we can inject the number of injection. We can have more than one in one cycle itself. It's not like that we need to inject all the fuel in only at towards the end of compression stroke. That is a single injection. But now with very advanced technology, there is a flexibility to have a multiple injection in one cycle. You may have 5 injection in one cycle if, well, that is what I have read, and I know that one of the very advanced system can have a 5 fuel injection process in one cycle. But normally 3 is very common nowadays. 3 injections in one cycle. One is before the main injection. Main injection here I'm saying what it is injected, the whatever the quantity is injected towards the end of compression, stroke. So that is before that, and even one is after that, during the expansion stroke. So these are the some of the things we have to be when we are designing the diesel fuel injection system. So these are the some of the important things we need to keep in mind, said how we can improve the fuel injection pressure, how our control system can be in such a way that we can have more number of fuel injection per cycle. Okay, how we can improve the air fuel ratio, that is a responsibility of the fuel injection system as well as the design of the combustion chamber. And so that we can get a very smooth combustion, lower emission, high power output. So these are the requirements, or these are the features that the fuel, as soon as fuel comes into the combustion chamber, then these are the physical process that it has to go. First of all, it has to go to atomization, then penetration, vaporization, mixing with air, and then finally combustion. So as soon as the fuel comes into the combustion chamber, before it combusts, it has to go through the several physical process. Okay, so I will stop, and then in the next class we will discuss about the technology, that which technology is currently being used, what are the older technology, all these things we will discuss in the next class. If you have any questions, please ask. Any question?
So can we go throttleless with the help of GTI?
With the help of GTI. Once again, hello. Please repeat your question.
So can we go throttleless with the help of GTI?
Yes, there is a possibility. Yes, there is a possibility that if it is a diesel engine, if it is a GDI engine, there is a possibility to we can remove the throttle. Anything else?
So you had explained that fuel pump is a positive displacement type of pump. So
In PFI engine.
yes, sir. So flow rate is usually constant for positive displacement type pumps. So does that mean that the fuel pump is switched on and off very frequently depending on operating conditions, or does it remain on?
It always remains, but the things is we are always using a rail, okay, in which there is a already fuel is accumulated at the required pressure. And there's a continuous we are injecting also. So when you are injecting the fuel pressure is going to be down, so it has to be maintained. So it is continuously on condition. Otherwise, we have to maintain the constant pressure. I would say that at least you can see just, I hope that you can see at least what about the technology we are discussing it here, which kind of the car, okay, or which kind of the two-wheelers is equipped with that. And at least you can do for your general knowledge. It's not for the academic requirement, but for the general knowledge, these are really very important. Because let's suppose if somebody is going to discuss with you at this level, at the UG level, okay, instead of going to too much details in the technicality, general knowledge, they will start with the general knowledge. As soon as you say that I know the GDI, the very basic questions comes into the mind that which car has a GDI technology. And if you don't say anything, then it's not going to be a very good impression. So at least you must know that which technology is how it works and whether it is in current production state. If yes, then which model is equipped with such kind of the technology. Okay, so let us close the session here. Okay, and maybe I will meet once again with some of you in the lab class today. Thank you, all of you. See you in the next class.